Welcome back to CTN. I'm your host, Robert Van Sluten. This episode, we're going to start talking about view geometry. Let's get started. Core graphics is the low-level layer for supporting the graphics system. There are some basic data types. There's a notion of a point, 2D. There's the notion of a size, which is a height and a width. We're talking about rectangles here. And there's the notion of a rectangle. These are actually C structs. We're down in the C level. And it's what you'd think it would be. However, they are floats, the values. In other words, a point is represented by X and Y, but it's a float value. CG float is actually type def to a double or a float, depending on whether it's 32-bit or 64-bit. The type def statement at the bottom of the struct definition just makes it possible not to have to type struct when you used one of these things. It's a C trick. A size is a width and a height, and a rectangle has an origin and a size. There's three helper functions for actually creating these things. In other words, there's a function for making a point, CG point make, one for making a size, and one for making a rectangle. Check out the documentation. You can look for CG geometry reference. And there's a whole bunch of additional helper functions in here. We're talking about views here. Now, how do you create a view? How do you add it as a subview? Well, first you have to create a rectangle which defines the origin of the view and its size. Then when you create the view, and this is the standard UIView alloc, and then init with frame. And the frame is the view rec that just created in the previous line of code. Now, assuming I have an object that has a view already, in other words, I'm adding a subview to a view, and view controllers do have a view property, I would invoke an add subview method on the view that I'm adding the subview to. Just to review, the rectangle is created using this rec make. So we have an X and a Y and a width and a height. Now graphically, what are we talking about here? Well, think of the view, the self.view is being the gray view. There's a grid drawn in this particular view. And the subview being the red square. Even though floats are used for the basic CG types, the system deals with points, which are actually integers. That sounds like a contradiction, but they're floats to support the mathematics, and in actuality, when it actually comes to putting pixels on the screen, those floats are used as integers. A little different than most systems, the origin, the 0, 0 point for views, is the upper left-hand corner, not the lower left. This is different than most mathematics, and it's also different on the Mac. So we've created a rectangle that is 200 by 200, and we've located it at 50-50. Now keep in mind that the subview will also have an origin of 0, 0 in its upper right hand. So any subviews that are added, that's the new coordinate system, and any drawing that's done within the UIView view would be based on that coordinate system. Views have properties, and it's no surprise that there'd be a frame property. We did use a frame to actually create the view. There's also a center, which is actually the location of the center point of the rectangle. And there's the notion of a bounds. Now, it is a rectangle. It turns out the position is always 0, 0. It's the size that's actually the key thing. How big is it? Now, these three things are interrelated. If you change the bounds property, it's going to recalculate the frame. If you change the center, it'll recalculate the frame. Bounds doesn't really care where it's located, so changing the center isn't going to affect the bounds. That'll become clearer in the next slide when I do a little demo. There's another parameter, and I'm not going to go into the mathematics of this, but there's something referred to as an affine transformation, which is actually a matrix. It's matrix multiplication, which is used to do rotations of views. Let's go to the next slide for some clarification of this. I have an application running in the iPad simulator. In this particular instance, the purpose is to clarify what I just attempted to try to explain. We're not actually going to build this or figure out how it works, at least not at this point in time. I have a red subview. The superview, this background view, has a grid drawn on it, which was drawn using Core Graphics. The origin is, of course, at the top left, and the size of this in points is 500 by 500. We have some numbers indicated here. The frame for the subview is, the origin's 50-50 and the size is 200-200. And if you look at the graph, you'll see that that is correct. The position, which is the center, is at 50-50, and the bounds size is 200-200, which is the same size as the frame. Let's ignore anything relating to anchor point. Now, with some sliders here, I can change the position, for example, in the X and Y coordinate. And I can also play with the size. I can also reset the sliders. Now, the way in which that's done is by affecting, when I change the position, I'm changing the center property. And you'll notice that the frame changes also. That changing the center by changing the position recalculates the frame. When I change the size, I'm actually changing the size of the bounds. Which is also causing the frame property to recalculate. Now here's when things get interesting. The frame is actually the rectangle in which the subview exists. Okay, now what I mean by that is if I rotate, and I could do that with an affine transformation, if I rotate the view, the actual rectangle in which this view exists gets larger. The size went up to 279 in this particular instance. In the origin, which is the topmost corner of the region that this subview exists in, had also changed. So the frame, even though it seems simplistic when you actually create the view, actually changes as these other parameters change. Now, conversely, if you go in and change the frame, it will affect the other parameters also. I know that's a rather obscure set of complex relationships to digest, and you may want to go back and review the episode, take a look at the core graphics documentation, and of course read the documentation on UIView. Thanks for watching.